Good morning and welcome to your science lesson. For this lesson you will need your usual equipment and a calculator. All of your notes should be made in your homework book and they should be set out as if you were in a lesson. You should have already completed the low stakes quiz. If you haven't, pause the video and go to the timetable and access the link. Complete the 5 questions. When a solid turns to a gas, this is rare, it's sublimation. When the amount of reactant is more than can react, it's in excess. Specific latent heat is the energy needed for 1 kilogram of a substance to change state. Used to explain differences in density. Density times volume equals mass. And the total amount of kinetic energy and potential energy of all particles in the system, internal energy. Hopefully you got them all right. So the title of today's lesson is Using Moles to Balance Equations. Write that title at the top of your page or at the next available space, underline it with a ruler and put today's date in the short form. So our learning objectives for today: balance an equation given the masses of reactants and products, calculate the masses of reactants and products from the balance symbol equation, calculate the masses of reactants and products from the mass of a given reactant or product. More maths. The balancing numbers in a chemical reaction can be calculated by using the moles of substances in the reaction. So we have 3 steps. The first step is to calculate the moles of each substance. The second step is to find the simplest whole number ratio between the values. And the third is if the ratio is not a whole number ratio, you need to scale it up. I will walk you through this example. You might wish to have your whiteboards at hand so that when we finish describing it, you can make some notes. But I'd like you to listen now. 1.2 grams of magnesium reacts with 0.8 grams of oxygen to make 2 grams of magnesium oxide. We have to deduce the equation for the reaction. So using the information that we've just been given, we are going to work out what the equation for the reaction would be. So remember our steps. I've got them in the box here. Calculate the moles, find the simplest whole number ratio, and then scale it up if needs be. Magnesium you've seen before. It's often in this ribbon form, and this is what magnesium oxide looks like. It's a white powder, and if you burn magnesium in a Bunsen flame, this is what you get. So the first step is to write out the reactants. And then I'm going to write out my product. Then what I'm going to do is to put the masses that I have. And I'm actually just going to use my ruler to draw a line across the page. Now I need to know what the atomic masses are for magnesium. So magnesium is 24. I get that from my periodic table. Oxygen, 16. And then magnesium, well, I happen to know that magnesium oxide is MgO. So that will be 24 plus 16, 40. So using our equation of moles equals mass over Mr, so I take my mass, which is 1.2 grams, and I'm going to divide it by 24. Feel free to use a calculator, but that is 0.05 moles. I'm going to slide my page up a bit. Let's do the same for oxygen. So moles equals mass over Mr. So this time I've got 0.8, there it is, over 16, which is actually going to give me 0.025 moles. Please use your calculator. I'm putting the lines in just to make it a bit clearer for you. And then finally I've got 2 grams over 40, which again equals 0.05 mole. So I've worked out how many moles I have of each. Now remember, we need to find the simplest mole value. So if I divide everything by 0.025, that'll tell me my smallest value. Well, the 0.025 goes into 0.05 twice, once into 0.025 and then twice. So I have 2 moles of magnesium reacting with 1 mole of oxygen to give me 2 moles of magnesium oxide. So therefore my equation must be 2Mg plus O2 to 2MgO. We have a balanced equation, having worked out moles. Here is another way of presenting it, which fits a bit more simply onto my page. Everything that we've just done is on there. I've highlighted 0.025 moles in yellow because it's the smallest value. So if I divide by that, I get 1. I would recommend that you have that example in your book, because we're going to have a go at another one. Sorry, there's my balanced equation. This time, 0.81 grams of aluminium reacts with 3.2 grams of chlorine to make 4.01 grams of aluminium chloride. Deduce the equation for the reaction. Again, we've got to write out the reactants and then write out the products. I'm going to just use my ruler, making a very simple table. So aluminium reacts with chlorine to make aluminium chloride. Aluminium is Al, chlorine is Cl2 because it's diatomic, and aluminium chloride is AlCl3. So using my periodic table, I should be able to work out the formula masses. Aluminium is 27. Chlorine is 2 times 35.5, which is 71. Aluminium chloride is going to be 27 plus 3 times 35.5, which is 133.5. Having worked those out, I'm now going to use moles equals mass over Mr. So the aluminium, I've got 0.81, that's my mass in grams, over my Mr, which is 27. And actually, I would like to just put all these in. She says putting the wrong number. 3.2 divided by 71, and then 4.01 divided by 133.5. So then I get my calculator out and I do the maths. So I get 0.03, 0.045, and 0.03. Next thing is to work out the ratios. Well, if I divide them all by 0.03, I get 1 here, I get 1 here, and then here I get 1.5. So that's the ratios. So therefore, if I've got aluminium, and I've got 1.5 Cl2 to AlCl3. The problem is we don't usually use decimals. So what I'm going to do is I'm going to get rid of that decimal point. So actually 2Al plus 3Cl2 gives me 2AlCl3. Table summary of all the information you need that we've just gone through on the page, and then there is my balanced equation. Again, make sure you've got a note of that in your books. Another one for us to have a go at. So we're told that propane reacts with oxygen. And actually for this one, we're not told what the products are, although I do know the products of combustion, and so should you: carbon dioxide and water. 2.2 grams of propane, 8 grams of oxygen. Propane is C3H8, oxygen will be O2. So we need to work out the relative formula masses. So this one is easy because it's 2 times 16, which equals 32. Carbon is 12, so I've got 3 times 12 plus 8 times 1, which is hydrogen. 36 plus 8 equals 44. Moles equals mass over Mr. So the mass is 2.2 grams divided by 44, and I've got 8 divided by 32 grams. You can do those on your calculator, please. Hopefully you agree with me, 0.05 moles and 0.25 moles. So we're going to divide by the smallest. So divide them both by 0.05. This gives me a ratio of 1, this gives me a ratio of 5. So therefore C3H8 plus 5O2 is what I need for combustion. There's my summary table. There's my ratio. One mole of C3H8 to 5 moles of oxygen. Remember, those products are combustion. It's a good one to know, especially as an example of exothermic reactions, reactions that give out heat. Right, you have some do tasks here. And as you can see, there are 2 pages of do's. I would like you to do all of them. So there's 6 questions there. I'll leave this up for about 10 seconds, so that gives you time to pause it. I want you to set it out exactly like we've been doing as I've shown you on the visualizer. And then you're going to email me, because I believe that you can't upload to Google Classrooms. You're going to email me proof of the work that you've done. Page 2. This is your final task. I would like you to use this information to answer the questions on the exit ticket. I look forward to speaking to you tomorrow. Please make sure that you did register for this lesson before time runs out. Bye.